Alright, yeah, so in today's session I'm going to talk about running AI on a Kubernetes cluster. So before I start, I'll introduce myself quickly. So I'm Ahmed. I'm a principal cloud consultant, Azure principal cloud consultant. I work at a company called Web3, and I create YouTube videos, have my own website where I write blogs, and this is my LinkedIn and Twitter account. Yeah, so the idea here is that like all of the major ChatGPT, Claude, Gemini, all of the AI that we use on a day-to-day basis is actually behind the scenes running on top of Kubernetes. So that's the only way the big AI labs can actually scale and can distribute their services all over the world. So for example, one of the biggest distribution of all is ChatGPT, which is all running on top of Azure Kubernetes service. But as you might know, like with the economic scale, they could serve AI at a cheaper cost. Running GPUs, running Kubernetes clusters is actually quite expensive, but it is still doable. So the goal here is to show you how can you deploy your own AI on top of Kubernetes to use it for inference, and also how can you run an AI agent within Kubernetes as well. Normally, if in a presentation, people just like show one line and it deploys the code, but behind the scenes, it's like below the iceberg. There's a lot of thinking. There's a lot of infrastructure below that. And as an architect, or like when you want to deploy AI, you have to think about the cost and security. You have to think about hardware. You have to think about observability. I've got a colleague of mine who's a Microsoft employee who's going to talk about visibility. So you want to understand who's using your AI, what is it being used for, and all. And of course, how do you scale it and for more user, and how to make it reliable. And as you might expect, that's a lot of thinking. It is quite difficult to do so. So for that, Microsoft has built some tools, and I'll talk about them in a second, to help streamline this process, so you don't have to literally think about every single line of code for you to run your own AI on top of Kubernetes. So the first thing first is that this is, like, just to make sure, this is not a cheaper way to run AI. So like, there's a lot of open source AI models, like there are literally thousands of them, if not more, available both on Microsoft Data Foundry, available free on Hugging Face, and there's all. And if you look for an AI model, there's definitely an AI model that is serving a specific case. So if you look for, if you're looking for like an AI model to help with diagnosing a specific illness, or like if you're looking for a vLLM, which basically takes photos and video as an input, there's always a model for it. Running that on your own hardware, running that on your own Kubernetes, the idea is not going to be cheap. So for example, like I'll show you using Microsoft open source LLM called 5.4. And if you use the Microsoft Azure Foundry, which is basically the managed AI instance of it, it might cost you like $90 a month if you use it a lot. But if you want to run it on your own, it might turn into like a $30K, maybe not that expensive, but still it will be expensive. But why would you? In that case, why would you actually want to run AI on your own hardware if it is expensive? It's more expensive, not cheaper than models provided. And that is for all sorts of reasons. So for example, if you really want to control your data, so like if you have if you have data set residency and sovereignty, if you really don't want to share your data with AI providers, third-party AI providers, if you want to make sure that whatever work you do, and the LLM is in your control, the data is in your control, it's all protected, so that's why you would want to run AI on your Kubernetes. So now that we have gone through the reason why you want to run AI on your Kubernetes, the first thing to think about is that you want to pick, you have 4 decisions for you. You need to pick a model, you need to pick a GPU, a graphical processing unit, you need to pick an engine and a platform. And I'll talk about those in a second. So the first thing we'll talk about is the GPU. So that's the one that I have used here. It's a very small GPU, NVIDIA. It's a T4. And the way that you pick a GPU, it's 2 things. First, how big is is the size of the AI model? So, for example, a DeepSeek model could be like billions of parameters, and literally might require, for example, an H100, 80 gigabyte of RAM, and that is literally could be like 100,000 K a year just to run that model. So there are multiple things that will govern why would you pick a specific type of GPU. What is the size of the model you want to serve? What is your budget? So Microsoft provides all sorts of GPU for you to run, and it's actually quite expensive, and you have to request a quota. So for example, for our example today, by default, when you have the Azure subscription, you don't have access to that NVIDIA model. So you raise a request for a quota request. If there is a capacity available, if it is approved, then you'll get access to that GPU. If not, you might need to open a support ticket with Microsoft, and they approve it case by case. The next thing is now that you've got your GPU, you have your own cluster. So you want to run, and you've also picked a model. So you want to run your own model, and for that you have what is called like an engine. The engine is basically what turns all these weights built into the model into a servable service. And there are multiple variants of it. We have the vLLM one, the most popular one. It's really fast, and we have SGLang, we have llama.cpp, C++, and then TensorRT, and all these come with their own features. So, for example, if you want just something fast and easy to deploy, you would go with vLLM. If you want something a lot more configurable, you would have a lot more flexibility, you would go with TensorRT, but of course it comes with a lot of complexity. So now we have picked the model, picked the GPU, and picked the engine. Next is the platform, and the platform is directly connected to our Kubernetes cluster. So you want to run your AI model on top of cluster, but you don't want to literally handwrite every YAML code. You don't want to control all the pods and have to run it all by yourself. And for that, there are multiple solutions. There is the KAITO one. This is a CNCF project, and it's on AKS. You could just literally enable it as an add-on. So what that means is that Microsoft manages the add-on for you for updating and installing and governing the AI, the operator. And again, there is the NVIDIA Dynamo, there is Kubernetes, and LLMD. And all these are different types of platforms that will help you pick a platform for you to run your own model, and will make it easy for you to deploy. What I have done here for us is that I have deployed, and I'll come back to the architecture, what I've done. what I have used a tool called the AI Runway. And the AI Runway is just basically a portal. So right now this is running on top of a Kubernetes cluster. If I click, for example, on deployment, you would see I have deployed Flying Mini. So that's the model I have picked. If I click on setting, this is the cluster that is currently running. So that's my cluster. And if we click on models, this is going to tell us what models do I have available for me. And so, for example, if you see right now, it says like I could run Quinn, Gemma, Fly Mini, Quinn 3B, and Quinn 340. And it also tells me if it is if it can fit in actually in my cluster or not. So that, because my cluster is actually quite small, it yeah, because the cluster is quite small, it says does not fit. So if I go and try to deploy it, it's going to say the system is going to attempt to scale up. So that is also part of what KAITO can do. So if you want to deploy this one, it's going to say you actually need one GPU and one replica, and you don't have that. As of now, you have one GPU available. So it is going to request to order scale. It's going to talk to Azure and say, you want to deploy this model? Our own cluster right now does not have enough resources into it, and we're trying to scale up, deploy more GPUs. If I have the quota, and if this is allowed to scale up, it will automatically scale up. And right now, it is saying estimated cost. This is going to be the cost of running my own cluster. So right now I'm paying 77 cents an hour for the cluster. In a month, if it's continuously running, it's going to cost $560. If I scale it up, depending on what GPU it will end up landing on, the price of course will increase. For example, to run DeepSeek, it's literally going to cost us $160 an hour to run it, which is $100K a month. The other thing that the AI Runway here gives us is that it also integrates with Hugging Face. So I could, for example, say DeepSeek, and it will search whatever is available in Hugging Face, everything that starts with DeepSeek. And as you can see here, there's multiple variants of it. There's the coder, there is the, what else do we have? There's a Flash version of it and so on. And it tells you all the engines that it could actually run on. So it says if you have vLLM or SGLang or TensorRT and all, it could all work on it. Any engine you have installed, it will accept it. If I go to the runtime here, it says, as you can see here, it says like we have KAITO installed. So all of this is open source, all of this is available with CNCF. And if you would have had to do that yourself, it would have taken us a lot of time because we would have to orchestrate a lot of things. The GPU, the cluster, the operators, the engine, the AI model. Right now, it literally turns it into a portal, and you can just select a model, select what type of GPU you want to deploy it on, and then you run it from there. Any questions? Yeah.
What one do you use this to?
What's that?
What one do you use the runway to?
The AI Runway?
Yeah, so is it like you already have a cluster and
Yeah.
you're testing on it before you deploy? Or?
Yeah. So you already have a cluster, and then you have you just run the cluster first. I have picked an AKS automatic, which basically comes with a lot of configuration for day one built in. And then once the cluster is ready, you want to deploy an LLM model into it. You install the AI Runway, and I have a GitHub repo that actually I was going to share at the end. So this one contains literally every single step of if you want to replicate that setup. It would, as I said, like it will be costing you like $1 an hour, maybe more, right? So if it's not cheap, like if you keep it running over the night, you might spend like $10 more, right? Yeah, so like everything, how to replicate this setup is actually available in this table. I have added even a lot of script and all, so it makes your job easier to do that again. But to answer your question, yes, the idea is that the AI Runway is that your cluster is ready, you project the AI Runway into it, and then you are inside here, like in this portal, and from there you could pick on that one, so just deploy and you just go ahead and deploy. Oh, when is it going to deploy? Okay. Yeah, so this is the, let me just zoom in a bit. So this is actually our cluster here. So this is my AKS cluster, right, with the GPU connectivity. And this is the GPU node. And basically what it does, this is the AI Runway. It talks to the KAITO, which is the controller, the CNCF controller. That CNCF controller needs to spin up this GPU node, right? And for it to do so, we use something called node auto provision, which is basically, if you know Carpenter, it's like an open source, CNCF project that as soon as you run out of resources in your cluster, it will spin up another node. But this one is provisioned. If KAITO says like I want a GPU, this one will auto provision, and you get the AI Runway dashboard, right? And from here you could just like deploy models from whatever you want, and it talks to AI Runway and goes through this process. And inside this node, you see like we have the vLLM engine, we have the Phi, and the KV cache. And after that, you get like an OpenAI compatible API, and from there you could just talk to it from a quota. So that is, why is it OpenAI? Because it's a lot of actually models try to mimic OpenAI, because the idea is that if you deploy OpenAI model within your environment, you don't have to reinvent the wheel. It's just like plug and play, switch the OpenAI model to your own model and it works. Yeah, so this is basically what it does. If I show you this. Yeah, so as I said, like you start with the model deployment, it talks to AI Runway, and that talks to KAITO. This one deploys our node through talking to node auto provision. It provisions the vLLM, the Phi model, the KV cache for it, and then finally exposes in plot. So that's that's basically how you deploy an AI model. You could deploy, and of course this all needs to be open source. These are not proprietary model like Claude and ChatGPT and all. But again, all of those are available either on Hugging Face or Hugging Face maybe basically. That's how you deploy. Does that make sense? Yeah. All right. All right. Now I'm going to move on to another topic, which is basically we have seen that you could actually deploy an AI on your cluster, and that is running on your own GPU, on your own cluster. You control all the data. But what is also useful is that you could use your Kubernetes to run an AI agent. And to understand what is actually an AI agent, so an AI agent is a process running in a container, right? And then it can take actions. So for example, if you've used like GitHub Copilot, or if you have used Codex, Claude Code, whatever of those models, it's basically what they call like a harness. It's an application, talks back to an API, whether that's through OpenAI or Anthropic, and then you ask it to, for example, you want to create an application, right? And for it to work, you would need to understand your own environment. You would need to use tools like use a batch tool, or like, for example, call an API, change a file name. So it takes actions, right? But for this is running on top of your own laptop, right? if you are in a business and you want to have an agent that is running on the cloud doing actions for you, right? And actions are all sort of things. Like for example, it could react to an event. Someone places like an order, and then you want an AI agent to react to it. As soon as the event happens, the AI agent wakes up, does some actions, it will triage the order, it will make a judgment, right? But the idea is that you want this agent to be running inside of a sandbox. And what I mean by a sandbox is that you don't want it to have access to an environment outside of what you allow it to do so. And for that, there is also another tool available, what is called as a card controller. And so basically, it's doing something similar to what KAITO is doing, but for a different purpose. So the card controller here is also spins up a container or a sandbox. In there, you could have an agent. And in this case, we picked OpenClaw, which is just basically a famous AI agent that could do work for you. But the idea here is that it actually comes with its own identity, comes with its own policy, comes with its own fencing, and all of that is governed by Microsoft. So when you give the agent an identity, that means it will be able to do some activities but not able to do something else, right? And also there is what is called the agent mesh. The agent mesh here is basically, that's one agent we can see here. The agent mesh is if you have multiple agents and you want those agents to talk to each other. So for example, like an event happened and one of the agents acted on it and wants to hand over the task to the second agent, and for that we will use the agent mesh. So it's basically a way of almost like a communication channel between your agents, and this is what the agent mesh is doing. And they all come and talk through this inference router. No matter if you have one agent or multiple agents, they all talk through one way out of this. And the reason for that is that you want to control the agents so that they will not act on their own, right? So like all agents in the end need to talk to a router. That router talks to an Azure OpenAI model. Now the difference here is that you're not running this model on top of your Kubernetes cluster as for inference. You're talking to an Azure OpenAI API. So in this case, it could be like any APIs, like it could be any model on Foundry. You don't have to run an open source model. And also, I gave this agent access to the internet for it to be able to search, right? So for example, if it's still working. Alright, so this is OpenClaw. This one is, as you can see, it's like a localhost. It is running inside a container, inside my Kubernetes cluster. I gave it access to the internet. For example, if I just send it a message, yep. So it is, behind the scenes, this is 5.4 minutes, right? And I could ask it a question, for example, can you let me know what what was announced in alright, so we have it. Right. Yeah, so it is actually, it was able to recover from its own error. So what it did is, it went there, I gave it an access to a tool called web search, and that web search talks to the DuckDuckGo, the neural search engine, the private one. And what it did is that it went there, searched online, came back and said like, these are the top things that were announced. I have never, did not tell it like what to search. I did not go tell it like search for the top 5 or whatever. It's, as you have seen, it's like really quick. It just went there, did the search, inferred what we have, and then come back. So this is basically, I gave it away outside of its own box. So it's within a sandbox, but I gave it away out of it, so I go, take an action, and come back. You might want to do that, or you might not, right? You just might not want it to expose it to the internet. You want to give it access to your own data. So you want to control it this way. Yeah, basically in here, we go through the workflow. You spin up your open floor sandbox. You have your inference router that talks to the Azure OpenAI, and then that comes with its own tools, access and policies, and then talks back to the web and gives you the response back. And again, it will reason through and then talk back to Azure OpenAI. And yeah, that's about it. Yeah. Do you have any questions or something like that? Oh yeah, I will upload the slide on essential file or put it in the repo, right? And if you like to reference the repo, it contains all the scripts, all the documentation, and also contains the HTML file. And you could definitely replicate it. The script is built in a way where you could just plug in variables and share that. Any questions? All right, thank you so much. Thanks, Ahmed. Cheers, mate. Oh, sorry.